Hello guys, in this video we are doing differentiation from first principles. So differentiating from first principles, we might be given a function and the question is asking you to differentiate it from first principles. So we have the formula which we are going to use to differentiate from first principles, which is f prime of x. F prime of x, only one, that one, it shows its first derivative. So the first derivative of our function f of x is equal to limit of h approaches 0, f of x plus h minus f of x over h. So let's have an example. F of x is equal to x squared minus 5x. Let's want to differentiate it from first principles. So f of x, from our formula C, we have f of x and f of x plus h. But on our formula, we are only shorting f of x plus h. F of x is given on the question. So let's find f of x plus h. In this case, wherever you are seeing x, you have to substitute with x plus h. So we have x here and x there. So we have x plus h squared minus 5 x plus h. Then we expand. This was x squared plus 2xh plus h squared minus 5x plus h. Oh, it's 5h. It becomes minus and plus is minus 5h. So this is our f of x plus h. Now we go back to our formula, f prime of x. So we substitute now, f of x, now we have our f of x plus h. But we don't leave limit of h approaches 0. So f of x plus h is x squared plus 2xh plus h squared minus 5x minus 5h minus, then you open a bracket when you subtract your f of x, because if your f of x is more than 2 terms, you have to open a bracket like that. X squared minus 5x all over h. So this is limit for h approaches 0 is equal to x squared plus 2xh plus h squared minus 5x minus 5h minus x squared plus 5x all over h. Then from there, we check like terms that can add or subtract each other. So we have x squared and subtract it with negative x squared, negative 5x plus 5x cos. So limit of h approaches 0 is left with 2xh plus h squared minus 5h over h. Then now we can see we have a common factor, so we have to factorize h here on the numerator. So our common factor is h, so we factor it out. H, let's not forget limit of h approaches 0. So we have h 2x plus h minus 5 over h. Then h and h cancels like that. Then we're left with the limit of h approaches 0, 2x plus h minus 5. On the position of h, now we substitute with 0. So 2x plus 0 minus 5. Therefore, our answer is 2x minus 5. That's our first derivative.